All right, let's finally finish up this Hamiltonian. We found the first order condition, the derivative with the Hamiltonian with respect to consumption equals nu, and nu is going to equal this. And then we took the derivative with respect to time because we're going to need that to solve the second. So I always recommend you just go ahead and do that right away. Let's take the derivative with respect to assets, and that's just going to equal nu times r minus n, which is going to be equal to minus nu prime. So let's write that down. That's going to be theta ct to the minus 1 times consumption dot e to the minus rho minus n times consumption to the minus theta e to the minus rho minus n times t. And we actually know the value of this nu because we found it over here. So we're going to plug that in. Let's erase, oh, that's not black. Let's erase this and just put in let's put in the value of nu, which is ct minus theta e to the minus rho minus nt. And the first thing that should jump out at us is that all of these e terms cancel out, which is great. So we'll divide everything by e. And we'll be left with ct to the minus theta rn equals theta ct to the minus theta minus 1 c prime t minus rho minus n ct minus theta. And then we want to isolate the c terms together. So we'll divide everything by ct minus theta. We have two of those. So this one will go away and this one will go away, and we'll end up with a ct minus theta here. So now we'll have r minus n equals theta times ct minus theta minus 1 divided, that's the same thing as ct to the minus theta minus 1 minus theta. So plus theta, this and this cancel, so we just get ct to the minus 1. So we're going to have theta c dot t divided by ct minus rho minus n. And then let's move everything that's not a c dot, or it's just nothing that's a ct, move it all to the other side. And I'll flip the equation around too. And we're actually done. This is the Euler equation. It's going to be c dot t over ct equals 1 over theta times r minus n plus rho plus n. So this n and this n cancel, and that's going to equal 1 over theta rho plus n. Sorry, r plus rho. And that's the Euler equation. So that's 3.5 points. I think in the tutorial Jed just started from giving you this, but a lot of the funny questions will be changing the intertemporal substitution function. So normally you are given that ct 1 minus theta over 1 minus theta equals u of c of t, but that won't always be true. Changing this is one of the ways to make Ramsey tricky. So it's good to know how to do this. And then the last part of the question A asks us to write down the transversality condition. And so just so we remember, the transversality condition is that the limit as time goes to infinity, so when the sun blows up, assets price will be equal to 0. So just saying that before the world ends, you have to consume everything. Don't leave anything behind, because that doesn't make any sense. Remember that this doesn't mean that there's a selfish generation that won't leave anything for its kids, because in Ramsey there's a dynastic household. So the household goes on forever, and it thinks about its kids via this consumption function, this intertemporal substitution. This is how they think about kids moving through the time. And then this is just saying that at the end of the world, nothing will be left, at the end of the dynasty. if you will, if you don't like my exploding suns. Okay, and then the next part we'll do question number B.